Hello everyone, this is Learning Target 24, which is about using graphs to calculate the work done on an object. So if we have this graph right here, and I asked you to calculate the work, we could do that using the equation we already know. Work is equal to RF cosine theta. Now here we aren't given much information about direction. All we really can do is whether the force is positive or negative and whether the distance is positive or negative. In this case it looks like whenever the force is positive, the distance is positive as well. So we'll say that the angle is 0 here. They're in the same direction. So work in this case would be equal to the distance, which is 15 meters, times the force, which is 10 newtons, or work is 150 joules. Now if I asked you to calculate the area underneath this curve, underneath this red line, do a little calculus, we could do that just by considering this to be a rectangle. And so the area of a rectangle is equal to length times width. And in this case, the length is 10 newtons or 15 meters, whatever you want to call that here. Say 10 newtons, and the width would be 15 meters, and the area ends up being 150 joules, the same as we got up here. Now that's not a coincidence. Whenever we do a graph like this, the area under the curve of a force versus distance graph, or force versus position graph, is going to be equal to the work. So let's do another one like this. If we had this one where force is changing, now the equation work equals RF cosine theta, we can't really do this one because the force is changing. Do we use the starting value for the force or the ending value for the force, or what do we do here? Well, the area still works, so the work is going to be equal to the area of this triangle. So work then is going to be 1/2 base times height for that triangle, which is 1/2 15 meters times 10 newtons. So work is going to be, let's see, 1/2 times 10 is 5, times 15 must be 75 joules. Now what if we have a little more complicated shape, like this one? We can still do the same thing. It's going to be useful to break up our graph into shapes that are easy to calculate the area for. So I see here that I've got a little triangle there, a little rectangle here, bigger triangle here, and then another triangle, but this one is negative. So I need to calculate the area for each one of these pieces now. And I'm going to make a mental note here that when I do this triangle, the negative one, I need to subtract that from my answer. So the work here is going to equal, let's see, the area for this triangle would be 1/2 times the 5 times 5, so that'd be 12.5 joules. For this little rectangle, it'd be 5 times 5 is 25 joules. For this triangle, we've got 1/2 times 5 times, looks like about 7 there. So that 35 and then 17.5 joules. And I made a mistake here. That little triangle, that actually just has a height of 2. So 1/2 times 2 times 5 would just be 5 joules. There we go. And then this one, we've got 1/2 times 5 meters times -5 newtons, so that'd be a negative 12.5 joules. So the total work is 25 joules plus 5 joules plus 17.5 joules minus 12.5 joules. So the total work on this one is going to be, it's 5, 10, 35 joules.